Le Chatelier's principle. Voice is off, paying attention, get out your notes, let's go, here we are. Now, Le Chatelier's principle in the demo too, I can go back to that, but stress is applied to a system at equilibrium. The system proceeds in the direction that relieves the stress. Stress of any kind is a change in the system that upsets the equilibrium. So there are these three factors: concentration, temperature, and pressure. Now we covered concentration and temperature. We did not get over or talk about pressure just yet, but do recall, like here, that the reaction will initially shift or proceed to a certain side. In order to start relieving the stress, it continues to go back and forth until it ends up getting back to that K ratio of products over reactants. So we initially say, though, which side it's going to proceed in order to start correcting the disturbance. Now, as I stated before, increasing concentration or adding stuff to one side makes it go the other direction. So if you add concentration of something to the reactants, it will proceed towards the products. If you add something to the product side, it's going to proceed towards the reactants and go the reverse. Keep that in mind. Okay, so it's easiest way to remember between heat and concentration. If you're adding it in and it's on that side, it goes the other direction. Now, here, increasing CO, of course, CO happens to be a reactant, so in this case it's going to proceed towards the products to reestablish equilibrium. But if we start taking away or removing substances, okay, here removing water, taking water away, the opposite occurs. If you remove something from a side, it goes to the same side you removed it from. It wants to replace it. It's going to try to reestablish the ratio of products to reactants. So if I remove water, it's going to proceed towards the products and make more products. If I were to remove, say, hydrogen, take this out, it's going to proceed towards the reactants in order to make more hydrogen. Now going back over the temperature ones, here's an example, SOL kind of question. What will happen if more ammonia is added to the system, which is at equilibrium? Well, we're adding to the product side, so which answer seems the most reasonable? We add to the products, it's going to proceed towards the reactants. So that would be the best choice in selection there. Now, heat. The thing about the heat, you are adding and subtracting it the same way as concentration, but you need to know what type of reaction it is before you can even start looking at it. You have to know where the heat is. Is it a reactant or a product? Is it endothermic or exothermic? If it's an endothermic reaction, heat will be a reactant. Now they will tell you, they will either put heat as a reactant or they will give you a delta H value. If delta H is positive, they tell you it's positive, then you know it's endothermic and the heat belongs on the reactant side. If delta H is negative, then you will attach the heat to the product side. Once you've figured out where heat goes, now you can add it in or remove it and figure out which way it should proceed or shift. So, in an endothermic reaction, if I add in heat or increase the temperature is another way to phrase that, it's going to proceed towards the product. But if I remove the heat, okay, then it's going to proceed towards the reactants to replace the heat. The opposite is true, of course, on exothermic reactions because heat is over here. So if I add in heat or increase the temperature, it's going to go towards the reactants. Proceed that way. If I remove heat, take out the heat, then it proceeds towards the products. So first thing, though, with the heat and temperature ones, you have to figure out where the heat is in the reaction, whether it's endo or exothermic. Okay? So if we took it away, it's just going to go to that side from which you took it away from. But you have to know, is it exo or endo? Now our demo here, we completed that, basically saw the pink and the blue ions as the different stresses were applied to the system, whether we added HCl or CaCl2. basically adding in chloride in both of those cases. When we added in the chloride, it shifted and it turned blue. When we added in the water, it shifted towards the reactants and turned pink. But when we heated it, it turned blue. So it turned blue. That meant that adding the heat, this must have been an endothermic reaction. So it proceeded to turn blue. When we cooled it down to remove the heat, put it in the ice bath, it turned a lighter pink. Okay? So basic things there. Now pressure, this is new. Pressure, if you increase the pressure in a gas of the reaction proceeds to the side with fewer moles. Now it says molecules, but I like moles better, because moles, you're looking at the number of moles in the reaction. If you decrease the pressure in a gas, the reaction proceeds toward the side with more moles. Okay, so just go with moles here. Let's see here, and if there's the same number of moles of gas on both sides, then there was no shift at all. It is no effect. And how am I looking at and deciding the number of moles? Look at the coefficients. This is a 1 here, this is a 3. That means there's 4 moles of gas on the reactant side. There's a 2 here. That means there's 2 moles of gas on the product side. So if I increase the pressure, it's going to shift to the side with fewer moles. In that case, it's going to go towards the ammonia side with less moles. If I decrease the pressure, it's going to go to the side. So this is for a pressure increase. For a pressure decrease, it's going to go towards the side with more moles. Now, the only other little glitch here is sometimes they don't ask it directly with the word pressure. What if they say they increase the volume? We know that pressure is going to decrease, so therefore it would shift to the side with, or proceed to the side with more moles. So they use Boyle's law here. You need to know the pressure-volume relationship. As volume increases, pressure decreases. They could also say if they decrease the volume, what would happen? And then you would have to realize, oh, that means a pressure increase, so it's going to shift to the side with fewer moles. Does that make sense? So that's the only thing. And for pressure, you're only looking at gases. Aqueous, liquid, solids, of course, don't apply here because gases are the only thing that actually exert pressure. Okay? So don't look at any of the other things when you're counting your number of moles. Now, just quick little go over this. So simply put here, and yes, even though it's not identified, this is the Haber process, this is the gas, this is a gas, and of course ammonia is a gas. And it should identify for you the phase in the reaction before you try to do it. So, if I add in hydrogen here, am I going to go forward or reverse? Proceed towards the products or proceed towards the reactants? I'm adding in hydrogen, this right here. It's going to go to which side? Product, so the forward, okay? Forward reaction goes that way. Now, if I'm making more ammonia, going that direction, what happens to my amount of nitrogen? It should decrease, yes. What would happen to my amount of ammonia? It should increase, okay? If I add in ammonia over here, which way is it going to proceed? Towards the reactants or the reverse, okay? Reverse, go that direction. Now what happens to your nitrogen? Increases. What happens to your hydrogen? Increases as well. You're making more reactants, so therefore that should initially increase. If I remove nitrogen, which way should it proceed? I'm taking the nitrogen away. This is going away. So we would go reverse towards the reactants. Yep, that away again. So that means the hydrogen's going to increase. What happens to the ammonia, though? It's going to decrease, yes. So you're kind of getting the idea here. Let's just quickly do these. Removing hydrogen means what? Reverse. It's going to proceed that direction. You're going to increase your nitrogen, decrease your ammonia. removing ammonia, taking it out over here on this side, means the forward. Going to go towards the products to replace the ammonia. That means nitrogen decreases and the hydrogen decreases. Now, looking here at the temperature, what do I need to focus on? Where the heat is positioned. It's over here. This is exothermic. So if I increase temperature, I'm adding in heat. Heat is a product. Which way is it going to go? Reverse. Very good. It's going to go the other direction. All right, so that means nitrogen increases, the hydrogen increases, the ammonia is going to decrease. Decrease in temperature should be the opposite, right? Go towards the forward, producing more heat, therefore the nitrogen decreases, the hydrogen decreases, and the ammonia should increase going towards the products. Now, for pressure, let's look at moles. Once again, we have 4 moles over here of gas to 2 moles of gas. So increasing pressure shifts to which side? The one with the fewer moles, which happens to be the products. So it's going to shift in the forward direction, proceed in the forward direction. So we decrease, and increase. And I know this one's not on your page, but let's go over it anyways. If you decrease the pressure, it's going to go in the reverse, obviously, because it's opposite. It's going to the side with more moles of gas. So this one's going to increase, and ammonia should decrease. Okay? So keep that in mind, follow those rules. There'll be a couple of those on the quiz. Any questions?